Charles Steinmetz was a German-born electrical engineer and mathematician, born in 1865, who was a professor at Union College in the early 1900s. His work was prominent in discovering alternating current, which is what powers much of the world now. And today we're talking about his development of the Steinmetz solid, which is an intersection of two pipes or three pipes of radius 1, which creates a unique looking solid. And so in order to determine the volume of the Steinmetz solid, when looking at it in the XZ plane, as right here, it appears to be a circle, and also in the YZ plane, it also appears to be a circle. But ultimately, this is the shaded region is what it would look like as a 3D object. But in order to solve this for the volume, what we first do is take the definition of volume using triple integrals. The volume over the region R integrated over the z-axis. And so we have from -1 to 1 is our x-coordinate. From -1 minus x squared to 1 minus x squared, the square root of 1 minus x squared, is our y-coordinate. And then our z-coordinate is the negative square root of 1 minus x squared to 1 minus x squared. From there, when we integrate the first integral with respect to z, we get the integral of -1 to 1 and negative square root of 1 minus x squared to square root of 1 minus x squared of 2 times the square root of 1 minus x squared. Integrating once more, we get that doubled, and then integrating that in relation to x, we get 4 times the integral from -1 to 1 of 1 minus x squared dx. And from there, integrating, we get 4 times x minus x cubed over 3, evaluated from -1 to 1, which gets us to 4 times 2/3 plus 4 times 2/3, and 4 times 2 is 8, plus 4 times 2 is 8, which is 16 over 3. So that's evaluating it in the XZ plane, and then evaluating it in the YZ plane. It's very similar, except the y coordinates or the y bounds and the z bounds are from -1 minus y squared to 1 minus y squared. And so evaluating that, we get to the same result, which is 16 over 3.